Okay, so I'm continuing to introduce everybody to the Dawsonal dodecagon, and this is the geometric pattern that's going to enable us to divide the circle into 360 degrees. And from that diagram, we're going to access the base 12 version of pi, or the Dawsonal version of pi, or just Dawsonal pi, which is a bit different than the base 10 version that we're familiar with. And I don't mean just in a rearrangement of a long string of patternless numbers. There's something really interesting in there. But we have to get there through the geometry so you can see the structure that gives rise to that number. So we're working on a Dawsonal Cartesian plane, or a base 12 Cartesian plane, where those 1 by 1 squares are divided into 12s instead of tenths. You can see this pattern. We start at 0, 0, and these lines here, this bottom one has a slope of going over 1, then up 0.7, over 1, up 0.7. And all the points that define its shape and the slopes and the connecting them are all distinct lattice points located on the base 12 Cartesian plane. So the distance from 0, 0 to this point, then that point, then that point, those are in sections of 0.96 root 2. So over here I've written out the progression of that series of that line in sections of 0.96 root 2. So 2 times that is 1.7 root 2, then 2.46 root 2, then the fourth perimeter as we grow the pattern is going to be 3.2 root 2. That's the distance from 0, 0. That's basically to right here. So we're going to be working on the fourth ring of the pattern to create our first ring of the diagram for 360 degrees. And so the perimeter of the dodecagon is made up of sections of 0.5 root 2. So the first ring is these 12 sections of 0.5 root 2, or 1 in each sort of quadrant or section of the dodecagon. Then it's 2 times that, 3 times that. So we do that same pattern here. We're counting in 5s in base 12. So 2 times 0.5 is point dec. 3 times that is 1.3. One group of 12 plus 3. One group of 12 plus 8 for the fourth section. And then multiply that by a dozen. And we get 1 do 8 for the complete perimeter of the fourth ring. And again, that's the ring that we're going to be working on to create our first ring of the diagram. I'm just going to show you what this all looks like on a large sheet of paper where we just keep continuing with the pattern. So you can see that's what it looks like. Again, it's the same thing, just more. So it's one of the challenges of working in base 12 is that all of the geometry programs and all of our technology is built in base 10. So we have to go back to chalkboards and graph paper or I have to do that to illustrate what base 12 looks like on a base 12 Cartesian plane.